Okay, so continuing on with our Python script, in this video we're going to create a function that's going to allow us to walk through our description files line by line and build up all of the information we need to then go ahead and render our parsers. So what information am I talking about? I'm talking about instances of our render info that's going to store our objects, lights, our parsers, in terms of parse type, our object name, and our light name. Now you'll notice I've closed out the Python shell since we didn't need that anymore, so I am just looking at the scene view, but that's not important for building this script. So I'm going to right click on our tool and come down to edit tool so we can continue working on our tool, and let's create the load description file function. So I'm going to define a new function. You'll notice this definition is outside of our class, and I'm going to define a load description file function, and I'm going to pass a parameter to this function called dfile. What dfile is going to be the file that we wish to load in. So let's take a look at how we go about calling this particular function. We'd call load description file, and we pass to it a file. For example, we could pass c / myfile.txt. So when we call load description file, we pass c : myfile.txt. that will be stored inside dfile. So whenever we're in load description file, we can access c / myfile.txt by accessing dfile. So let's jump inside our function and tab inside so that we're dealing with the body of the function. And the first thing we're going to do is create a comment, because we're going to be commenting our code throughout this script to make things nice and clear. And in Python, comments are denoted by using the hash key, and a comment is basically a line of code that will not actually be executed. So what are we going to be doing? We're going to be opening the specified dfile, and to do that we're going to create a file object and call on open, passing in dfile as the file we wish to open and opening that file for reading. And then once we have that file open, I'm going to jump down because we know later we're going to need to close out that file. So in between having this file open and closed, we're going to basically walk through this file line by line, and based on the commands that it finds in that file, we're going to have to act in a number of ways. Now before we do that, there are a few variables that I'd like to initialize. So let's create another comment that says we're going to initialize our variables. The first variable I'm going to initialize is going to be our render node, our R node. Once we call on, if we jump over to our description file, when we call the render node command and pass in a render node, we're going to save into this variable basically the render object, the node object from Houdini that represents our render node. I want to initialize that out to none so that we can tell in that script if we have yet called the render node command or not, and that's going to be important because we're going to need to deal with our render node with a lot of our commands, and we don't want to call those commands if we haven't yet specified a render node. I'm also going to default shot name to an empty string, and fbase for our file base to an empty string. And when we call upon the global commands of file base and shot name and pass in various strings for those, we're then going to save those into these variables. Finally, I need to deal with having a system whereby we can easily create instances of render info and know how many we have, and also have a single location that stores all these. So I'm going to create a counter, which is a basic integer variable called render count, that's going to count how many of these instances do we have. And I'm also going to create an array, which allows us to store instances of these render info classes one after another. So that's going to allow us to keep adding new instances on top of the other instances. So we're going to create an array. I'm going to create an array called render list, and I'm going to default that and initialize that to an empty array by using open square bracket and close square bracket. So now we're ready to actually walk through our file. So let's loop through every line of the file. So the first thing I'm going to do is load in the next line so we can compare that against an empty string and see if we need to continue looping. So I'm going to call on our file object. I'm going to call on the readline method of that file object, and while the result of that, while next line does not equal an empty string, that means we've got some data coming back from our file, as I misspell next line, there we go. Well, that's not equal to an empty string, that means we're getting lines coming back from our file, so we can keep looping around. So I'm going to drop inside, and at the end of this while loop I'm going to simply say, okay, that next line is equal to fobj.readline. So what we're going to do, we're going to keep looping, keep loading in the next line until the point where we hit the end of the file. Now, you saw inside of, let's jump up, inside of our description files, it'd be nice to be able to put in some white space, just have some blank lines and not worry about them. So what I'm going to do is skip through the looping. If we hit an empty line, we're simply not going to worry about dealing with commands or anything. So I'm going to skip if empty line. And basically, if our next line is equal to the new line character, which means it's an empty line, then I'm simply going to, well, if it was equal to new line, then we'd want to do it on new line. I'm going to set it not equal to new line. So as long as we aren't a new line, we're going to execute the code that's indented and belongs to this if block. So we can knock that down a line as long as we keep our indentation nice and clear. So all the time it's not a new line, we need to do a little bit of basically processing to our line that's come in before we can work with it. You saw when we were loading in a file line by line that we were getting a new line character appended to the end, and that was creating that spacing of loading in our file line by line and having a blank line in between all of those lines. We don't want that new line character. If we were to jump over to Photoshop and were to call on, say, let's take a look, something like objects, and we were to say, okay, objects is equal to stadium import, when we load in that line, it's going to have a \n on the end of this line, which means if we were to take that argument and place it into our parameter in Houdini, we're going to have a \n placed into the parameter, and that would be really bad. So what I want to do is strip off the \n from every line that's coming in. So let's strip our line that's coming in of the new line character. And that's really easy. We can simply call on a method that belongs to nextLine. nextLine has a strip method where we can specify we wish to strip off the \n, but we do need to store the result that's coming back from this back into nextLine. So we're going to call nextLine.strip and pass in the new line character, so that's going to remove the new line from our string, and then we're going to save the result back into nextLine. So now we can be confident that nextLine does not have a new line on the end. So now we deal with actually tokenizing our string and splitting it into the command and the optional argument. So we're going to be splitting into command and optional argument. And we saw on the whiteboard that all of our commands, if they have an argument, are split between command and argument by space equals space. So we're going to tokenize based on space equals space, which means we're always going to get at least one item, which will be our command, and then if we had space equals space, we're going to get a second item, which will be everything after that space. It's worth noting that if we were to have new render here and we were to end up putting a space on new render, that space will not get removed because we're tokenizing on space equals space and not just on space, which means it would treat new render space as a command and not just new render, which you'll see when we come to basically looking through to see what commands we've got. We're not using a huge amount of error checking, and that will actually throw our script into thinking it's a completely different command that it doesn't understand. So it is important to make sure when you're typing commands, if we use new render, we don't have anything after the new render command, and when we're using objects or any of the other commands, we have objects, a single space, a single equals, a single space, and then the arguments that we want to assign to that command. So let's jump back in and split our string based on the space equals space. So we can say that we can call on our next line, and it has a split method which takes in what we wish to split based on, and we're going to split on space equals space. They are single quotes either side of that string, and that's going to return to us an array of words. So for example, with our render node, it returns to us an array of nodes. In index 0, our first index of the array, we'd get the string render node. And on index 1, we get /out/mantra1. So let's store this into a new variable we can call words. So words is going to be our tokenized string. And that means that now we can say words 0, our index 0 of words, we can compare that to commands. And if we know a command takes an argument, we can then look into words 1 to find that argument. And you're going to see that throughout the rest of this function, we're going to rely heavily on comparing words 0 to known commands and then using words 1 as the argument for those commands. So let's take a look at some of the basic commands that we've got where we have filebase and shotname. So let's take a look at the specification first of shotname. So if our words 0, which is our command coming in, if that is equal to and exactly equal to shot name, that means we've just called the shot name command. And if that's true, we want to take the argument for shot name and store it back into this shot name variable we've created. So we're going to take, if that's true, we're going to take that shot name variable and store into it words 1, and that's the argument. So let's take a look back over in Photoshop. So if we hit the shot name command, this will be word 0. Words 1 will contain shot 01, which is the argument we passed with that command, which means that we're going to come in and store shot 01 into our shot name. So now we can get access to the string shot 01 by simply calling our shot name variable. Similarly, we can do the same for our file base. So specification of file base. So if words 0 is equal to file base, that means we've called the file base command, and in which case we want to store the argument into our fbase variable we've created. So we're going to store words 1, which is the argument, into fbase. So you notice we're not dealing with error checking where someone may have called the shot name or file base command and not passed an argument. We're simply keeping this script as simple as possible so that you get an idea of where we're going with the script, but it's not fully robust, it's not got a whole amount of error checking, because if we were to introduce error checking, things would end up 3, 4, 5 times as long and it wouldn't be as clear. And since this is beginner introductory Python content, we wanted to keep things nice and clear for everyone. So now we can go on to the specification of the render node. And why am I dealing with the render node here? Well, that's because we want to make sure that if we call any other command, we already have a render node specified. Filebase and shot name, doesn't matter if we specify the render node or not, we're simply remembering these, ready to set them later. Specifying a camera, specifying a start frame or an end frame, we need to know our render node so we can deal with acting accordingly. So that means what we can do is we can look for the render node command now and react accordingly. And if we hit any other command other than filebase, shot name and render node, but we haven't set render node yet, we know we've called a command before calling the render node command. Now in doing this, we're going to set up our if statements slightly differently. Instead of just having if and if, we're going to be using the elif command, which basically is an if, and if this is true, this will execute, and else if will not execute. If this is false, then we're going to check else if and take a look to see if this is true. If this is true, this will execute. If not, we're going to look onto the next else if statement, and so on, which means that as soon as we hit one that is true, we don't check against any of the others. So we want to first check for the specification of a render node. So elif words 0 is equal to the render node command. In that case, we want to set our rnode variable to point at our node that we have specified in Houdini. So instead of just storing words 1 into our node, what we're going to do is we're going to call on that hou.node function that we talked about in the primer video, and we're going to pass words 1 as the node that we want to grab using that function. So if you recall, we had hou.node as a function, and we could pass to that something like / obj / and then any of our nodes. Well, instead of passing a specific node, we can pass in words 1, so we're passing in our argument, which if you recall, if we jump to our whiteboard, is going to be in this case / out / mantra1. So that's going to return to us the node that we were after, and we can store that into our rnode variable that we set up and initialized up here. So that's going to grab our render node. Now, if any other command is found by this point, we want to basically drop out of this function because we're calling a command before having called render node, because we can check to see if render node is equal to nothing if we hit any other command. So let's say command called without specifying render node. And basically the check to see if a command has been called without specifying a render node, I guess we should say check to see if command called without specifying render node. If at this point our node is equal to none, what does that mean? That means that every time we've looped through this script and we've executed based on the command we've found, we haven't yet executed the render node command, which means we haven't yet set our node to equal something other than none, which is what it initialized to. that means that what we're going to do here is we haven't called shot name in this case, we haven't called file base in this case, we haven't called render nodes, we've called some other command, but in previous lines in our description file we haven't yet set our node, which means we've called another command without having yet set our render node, and we want to escape from our function if that is the case.
So the bottom line is, right here, you're making sure that if any other commands come through, that render node must already be set. You're checking to see if it is set. If it's not set, it's time to basically tell them that it's not set, them being the user, and then exit out.
Exactly, because we could then be calling on our camera command, our start or end commands, and we need to be changing parameters on our render node. If the render node hasn't yet been set, that's going to be really bad.
Exactly.
So if this is equal to none, we're going to print out an error message, and I'm basically going to print out that the command, and what command are we going to use? Well, we're going to pass a string, which in a second is going to be the command that which is stored in word 0, and we're going to say that this particular command was called without specifying a render node, and we can close that string, and then to pass in a string into that %s, we simply use the percentage sign, and inside brackets we can pass words 0. So that's going to take word 0 and insert the string stored in word 0 in replace of this %s. So for example, say at this point we called the camera command, it would say command camera called without specifying a render node. If that's not the case, that means we're happy to basically parse through our other commands. So parse other commands. So we can check, and I'm going to check now for camera start and end, and when we hit these we're going to deal with setting parameters on our render node. Other than printing out an error, it would be really good if we did actually drop out of this function, so I'm going to return from the function.
And that will take us out of the function.
Exactly.
Stop execution.
So that means we're not going to parse through our file anymore. I guess before we return it would be really important to close our file as well. So let's close our file, since otherwise we're only closing within that function, and we want to make sure that our file is not left open once we exit. So if our word 0 is equal to camera, then what do we need to do? We need to set the camera parameter on our render node equal to the argument that we just passed to camera. And we've seen how to set a parameter, so we've got our render node saved in our node. We can access its parameter. The parameter we want to access is camera. To prove that, let's jump over to Houdini, which we're already in. Let's jump over to here and grab our outputs. And we're looking for the camera parameter, which if we hover our mouse we can see is the parameter camera. So we're going to set that parameter equal to, so set equal to words1, the argument that we've passed to camera. Else if word 0 is equal to start, then we need to do a couple of things. We need to set the valid frame range parameter equal to, in this case, render frame range, which is 0, 1, because these are going to be an integer menu, so 0, 1, and 2, so render frame range will have a value of 1. And this parameter is the t range parameter, and then we need to set our start frame equal to whatever we've passed in, and in this case the start frame is the f1 parameter. So we're going to say rnode.parm and specify our t range parameter, and we're going to set that to a value of 1, which means whatever it's set to currently, we're now saying we're specifying a frame range. And then we're going to go ahead and say rnode.parm f1, which is our start frame, dot set to basically the value that we've passed in, but we're dealing with reading in string information, and we need a number here, we need an integer value. So we're going to take words1, which is a string, and we need to cast that over to an int. So we're going to pass words1 into the int function, which will cast it to an int, and then that's going to return an int and pass that into the set function, which will use that integer value to set as start frame. In the exact same way, we can set our end frame. So if words 0 is equal to end, then we're going to need to, again, just in case we called end before start, we're going to set the t range parameter equal to 1. And then we're going to set the end frame, which is the f2 parameter, to the integer cast of our words1, our argument. Now, just like when we were checking to make sure we had a render node before setting up any of our render node parameters, I want to make sure that we've called new render at least once before we set up any of our other parameters, basically our render specific parameters. So I need to make sure that at this point I now check to see if new render has been called, because after that we're going to be checking all of our other commands. So let's check to see if new render has been called. So if words0 is equal to new render, in that case there's a few things we need to do. We need to increment our render count, which if you recall, so render count, and we're going to plus equals 1. Render count comes in with a value of 0. We initialize it to 0. So say we hit new render for the first time, we're going to take 0 and we're going to add 1 to 0 and store it back in render count, so this will have a value of 1. Every time we hit new render, this will now increment to 2, 3, 4, and so on. So we have complete information over how many renders have we just set up. And this is going to be important for a few reasons, and we'll come to that shortly. The next thing I want to do is create a new variable called new render, and set this to be a new instance of that render info class that we created. So the render info class, if you recall, has our objects, lights, parse, object name, and light name. We've now created a new instance of that, which is like hitting new render here, and then we said create a new instance. So we've now got this new instance over here, but we need to put this new instance into the array that we were setting up, because currently it's just floating out in memory. So to put this into the new array, we can simply call our render list array, and our render list array has an append function, and if we append new render into that, that's going to take whatever is currently in our array and append our new instance of render info onto the end of the array. And that means that we can always deal with the latest render info we've created by always dealing with the last entry into our array. So if we hit new render, that's what we need to do. Otherwise, we're going to be calling a command before specifying a new render. We need to check for that, because at this point we're calling any other command like objects, lights, parse, object name, light name. We need to check have we actually set up a render when we've called this command. So let's check to see if a render based command was called without first specifying new render. To do this is going to work similarly to checking to see if our render node was equal to 1. We're going to check to see if our render count is equal to 0. If our render count is equal to 0, we're going to print out that the command %s called without creating a new render. And so I'm going to skip this particular command, but we can carry on to other commands. So I'm going to skip, and we're going to feed onto that words 0, which was the command called. And what I'm going to do, I'm going to continue. So what that's going to do is going to basically jump back up to our while loop and loop again, but you'll notice that we haven't then yet executed that next line call, so we need to make sure that we read in the next line before we loop back up, otherwise we would hit an infinite loop, and that would be really bad. So let's read in the next line and then continue back up and see if the next line is a valid command. If that's not the case, that means we have specified a render, and that means we can now parse our render-based commands. So we can check to see, does word0 equal objects? If word0 does equal objects, now that we've called new render and we've called the objects command, we need to take the argument passed to objects and store it into our latest instance of this array. So it's probably worth taking a step away from our script for just a second, talk about arrays and indices into arrays, and then we can jump back to our script. So as I grab the pen and grab a brush, so here when we instance our render info, we can imagine this being our array. We can think of this being the first entry into our array, and we saw that it had an index of 0. And this is our second entry into the array, and it has an index of 1. If we had a third entry, it would have an index of 2, and so on. Our render count, as we know, starts at 0 when we don't have any entries, then we have 1 when we create our first entry, 2 when we create our second entry, and so on. So we can see that our array index is 0 based, but our array count is 1 based. So if we had 1 entry, but we wanted to access that entry, we need to take 1 and subtract 1 from it to get 0. If we have 2 entries, but we want to access that latest entry, we take 2 and subtract 1 from it to get 1. So what we're going to do, we're going to take our render count, subtract 1 from it. That's going to give us the index into the array that represents the latest created render. So we're always dealing with the latest created render when we're calling objects, oname, lights, lname, or the parse command. So I'm going to jump back over into Houdini, and let's continue creating our script. So if word0 is equal to objects, then what we need to do, we need to access the latest entry into our render list. So we're going to use an index, and we saw that that index needs to be our render count minus 1. We're going to access that index, and we're going to access a member of that class that we stored in there. In this case, we're dealing with objects, so we want the O member. And we're going to store words1 into that member. So we're going to take the argument that we passed along with objects and store that into the O member, just as when we stepped through this, going through line by line within the whiteboard. So now that we've got words1 stored into objects, we can check to see, well, what if we called the lights command? So if words0 is equal to lights, then we need to grab our latest entry into the render list, so render count minus 1, and grab the L member of that particular render info class. And we're going to store words1 into that. The same for our parse. So if our word0, our command, is equal to the parse command, then we're going to grab the latest entry into our render list, and we're going to grab the P member of that class and store words1 into that. Same again for if we hit the oname command. We're going to grab the latest entry into our render list, and we're going to grab the on member and store words1 into that. And finally, if word0 was equal to the lname command, we're going to take the latest entry into our render list and save that into the ln member of that entry. So now we've ended going through and parsing our file. We need to make sure that we read in our next line. So let's make sure we read in next line, which is within our while loop. And that is actually going to end our while loop. So I'm going to create a comment that is indented correctly for the end of our while loop, just to make things nice and clear that this ends the while loop we created. We then need to make sure that we close out our file. So we've already got the code in place, so I'm just creating comments around that. So once we've closed out our file, we've actually gone through our entire description file. We've worked with our commands for render node, camera, start, end, etc. We've saved file base and shot name, remembering them for later. And then we've set up our array of render info, storing in our objects, lights, passes, object name, and light name as we keep creating new instances of render info. So we've got all of the information we need to now go ahead and actually render out the scene. And so what we're going to do for that is create a new function in an upcoming video whereby we pass through all the data we need into that function. So this is actually going to finish off this particular load description file function.
Let's go ahead and hit accept just to make sure we commit all of this.
Yeah.
Just in case.
And I'm going to bring back up our script because it'd be really cool to quickly throw together a temp description file and then load through that file, make sure that everything loads correctly. And then if we create a new function, just a temporary function, we could then loop through all of our information and make sure that we can print it out and see the information getting stored correctly. So I'm going to create a temporary function that's going to allow us to loop through the information and take in that information. And then once we have that in place, we can go ahead, create a description file and pass this description file to our function we set up.
Okay.
So the function I'm going to create is going to be something like temp description file print. and we need to pass in our render list, since we need to know our list, our array of our render info. I'm going to pass in our render node so we can get information about our render node. I'm going to pass in our shot name that we should have saved and our file base that we should have saved. And I'm simply going to print out the render node. I'm going to print out the shot name. I'm going to print out fbase. Now with our render node, we should be able to go in and evaluate some of the parameters that we know we might be setting. So let's grab our node, eval palm. What parameters? Well, we want to evaluate the camera parameter. Our node.eval palm. We want to evaluate f1, which was our start frame. And our node.eval palm. Let's evaluate our end frame as well to make sure that those were getting set, so they'll get printed out. We can also loop through our list of render info, and we can print out all the information for that render info. So here I'm going to print a new line, just so that we keep things nice and clear. And then I'm going to loop through our render information. So I'm going to say for, and I'm going to create, let's call this rinfo. So let's call this render item. So for render item in render list, what this is going to do is going to loop through every entry into that render list, and it's going to start off with entry 0, and it's going to store entry 0 into render item. It will then execute all of the code that's embedded for this for loop, and then we'll grab the next entry into the render list, store that into render item, and execute all the code. So what do we want to do when we're inside here? Well, let's simply print out render item.o. Let's print out render item.l for the lights. Let's print out render item.p for parsers. Let's also print out render item.on for our nickname for our objects. And let's print out render item.ln. After all that, I want to print a new line so that we have separation between all of our entries. With that, I'm happy with our temp description file print function. We're simply taking in some of the information from the file that we've just walked through, and we should be printing it out. We do need to make sure we call this function at the end of our previous function, otherwise if we load a description file, this function won't actually get called. So let's call temp description file print, passing in our render list, passing in our R node, our shot name, and our fbase, which are all variables that we had local within this function. So we're going to pass those through into our temp description file print function, and that function will now print everything out. So let's accept that, and let's create a temporary file. So I'm inside my C projects td vol2 folder. I'm going to right click, create a new file, which will be a text document, and let's call this temp description.txt. So what would a temp description file maybe look like? Well, let's take a look at a sort of mock-up example. First thing I want to do is go ahead and specify that we have a render node, and I'm going to specify /out/mantra1, which is the render node we actually do have existing in our network. I then want to specify a camera, and we'll use the shot. We're currently set to shot 01, so I'm actually going to specify shot 03 so we can see some changes occur on our parameters.
Sure.
For a start frame, I'm going to set a start frame of 20, an end frame of 30. So we should see our start and end frames change. I'll also set this over to render any frame so we can see that parameter get changed by our script. I'm going to set a file base of C /projects /td vol2 /renders, which while we're not actually using this currently for building our file names, we are passing that onto the temporary function and printing it out, so we should see that being picked up on correctly. I'm also going to set our shot name equal to shot03, and let's just create a few temporary renders. So let's say we're going to call new render. We're going to say our objects equal to stadium import, lights equal to bleachers bounce, pass is equal to diffuse, our O name is equal to stadium, and our L name is equal to bleachers bounce. And let's create a new render with the objects equal to pool, ladder, and stage. Our lights equal to main spot 1, main spot 2. Let's say that our pass is diffuse. Let's say that our O name is set, and let's say our L name is main spots. And let's do a third and final one. So let's say new render, objects equal to character, lights equal to secondary spot 1, secondary spot 2, secondary spot 3. So I'm using examples that have more than one entry for arguments, just to show that the entirety of this right hand side is being picked up on and stored into our various variables. The pass, in this case we can make a specular pass. Let's use an O name of character and an L name of secondary spots. So if we save this file, we can now jump over and bring up our tool. And what I'm going to do is, and this is the way we're going to actually be working with our tool in the future, is simply to, at the end of our tool, so after we've got all of the code needed for the script, I'm going to call on our load description file function, passing in the file that we wish to load, in this case temp description.txt, and then when we accept this and click on the tool, all of this code will get executed, and then the final line of the code to get executed will actually cause the code to run. So it will get sourced so that
it's stored in memory.
It's stored in memory, and then the final line of the code will actually cause that to run. So let's call on our function, which was called load description file, and we want to pass into that C : double backslash, since we're dealing with passing a backslash through, into the projects folder, double backslash td underscore volume underscore 2, double backslash, and inside that we had our temp description.txt. So we can accept that. You'll notice nothing will happen currently, and if we now run our tool, we got a huge amount of printout. We can see that mantra 1 was the node that we picked up on. If we bring up our tool, we can actually see what are we printing out. So our render node is mantra 1. The shot name is shot01. And our projects that's our file base. We obviously weren't actually printing out the result of evaluating those.
Yeah, we set those,
parameters,
which you'll be able to see in just a second.
Yeah, but you can see them over on the node.
Yep.
And then as we loop through each of our entries into our basically renders, we hit new render. So then we created a stadium import, which we gave a object name of stadium. Bleachers bounces the light, bleachers bounces the light name, and a diffuse pass. Then the next one we hit had pool, ladder, and stage as our objects. Set was the O name we gave. Main spot 1, main spot 2 were the lights. Main spots was the light name that we gave. Diffuse pass. Character with a character as both the object and object name. Secondary spot 1, 2, and 3 for the lights. Secondary spots as our light name. And finally specular as the pass type. So everything is getting read from our description file correctly and stored. Just to double check, let's make sure that our camera is set to shot 3, our start frame to 20, and our end frame to 30. So let's close that out, jump over here, accept this, and we can see our camera was indeed set to shot 3. We've switched from render any frame over to render frame range, start of 20 and end of 30. So everything to deal with loading in our description file, walking through that file line by line, and building up all the data we now need to go ahead and execute our renders has been accomplished. So with that, that's going to conclude this video.
I'd just like to throw one thing in real quick, and that is this small test that you did at the very end. This is very important. As you are achieving milestones while you're working your way through the creation of a script, it's always a great idea to test. There'd be nothing more disappointing than to do 5 times the coding of this, but have not tested your code even once, and then finally you think the entire thing's done, and now you're tracking down bugs all over the place. By testing with small additions to your script, as we've started here with our first edition, we've tested, everything works great, and we can move on. But if you run into problems, then you can back up, correct those problems, and then move on. I just wanted to say that. So with that, that will conclude this video. Thanks a lot.